About the project, so what I'll do is, because when we talk about cooling requirements in buildings, let me just share our initial analysis of working in few states, I think, and then maybe you may get some kind of a sense that how do we see the building sector growth in India. So let me touch upon Maharashtra. We looked at the commercial building segment growth or the commercial building segment presence in different states. Like in Maharashtra, the approach was that we looked at administrative divisions, we looked at all the districts, we looked at all the climatic zones, and then what we did, we also worked with electricity distribution companies. So this slide is very important for Maharashtra if you see this approach. When we were planning our policy interventions for the state, the key focus was that the one thing which we were just trying to have it from the market was that what is our commercial buildings segregation in Maharashtra. So what I mean by commercial buildings here is that as per the Energy Conservation Building Code, any building which is more than 100 kilowatt or 120 kVA, it is called as a commercial building. So if you see in Maharashtra, last 5 years growth, Pune and Konkan region, they mainly contribute, say, 80 to 90% of the commercial stock of the total commercial buildings in Maharashtra. What we did then, we also looked at the commercial establishment growth in the Pune city. So if you see this, for the last 10 years, what we have observed is that the annual growth rate of close to 20% in the commercial properties in Pune cities. Now, why we are looking at the commercial segment, why we are looking at the commercial sector growth? So when we also looked at the total built-up area in Pune, in the commercial area segment, as per some of the past analysis, when we talk about commercial buildings, 50 to 70% of the energy requirements is mainly driven by the cooling load. So so this is just an assumption, so the figures might not be 100% correct. We were just trying to establish that how much cooling load or how much cooling requirements, say, do we see in a city like Pune. So if I see, say, 60% of the air-conditioned area in commercial buildings in Pune, and so the air-conditioned area in Pune is close to 3.6 million square meter. So if I look at a conventional building, and in a conventional building, mainly closely for 100 square feet area, normally we go for a cooling requirement of 1 tons of cooling. So if we go by the efficient design, so we have a cooling requirement of, for 250 square feet, close to 250 square feet, 200, 250, we need 1 TR. So literally, if you see that if we go towards efficiency in our operations, if we reduce the cooling requirement, we have a reduction of close to 200,000 TR reduction in Pune city itself. This is all indicative, just to give you the example. Then if you see the energy consumption growth rate in Pune, so this is the actual data. So this is not based on any assumption. We collected all the data from all the distribution companies. So if you see this, and what we did, we extrapolated that. So by 2030, what we are seeing here is that Pune would be consuming close to 2,000 gigawatt hour. Presently, if I look at the 2017 figure, it is close to maybe 1,300 or 1,400. So when we talk about that in a total energy consumption in a commercial building, 50 to 70% of the energy requirements, they are for cooling. So you see that how much energy consumption we are targeting here. So literally, if I only talk about Pune, we are targeting about 625 gigawatt of energy. The cooling is only consuming up. So this is the energy consumption by the cooling segment only in the commercial segment in Pune. And if we are talking about the country as a whole, we have to decide that what kind of issue we are targeting here. So what is the outcome? Yes, that we see that the commercial segment is increasing. As Mr. Bhambure clearly mentioned, that 70% of the stock is yet to come. So we see a lot of commercial construction happening here. Then how do we address it? I think this one slide, I think this is also very important. This gives you an idea about the status of commercial buildings in all the 4 states. So the work is in progress. In Maharashtra, so this is not commercial building, let me correct it. This is total electricity connections in Maharashtra, in the commercial segment. So in Maharashtra, we have close to 10,000 electricity connections for the commercial consumers. If you look at Madhya Pradesh, it is close to 1,115, Bihar it is 365, and Odisha it is 426. So if you take example of Maharashtra, close to 1,000 new connections are coming up every year. So if we have a strategy, right strategy to manage it, I think we can address many issues together. We are talking about climate change, we are talking about refrigerants, we are talking about energy consumption. All these areas are associated issues, so we cannot maybe segregate these issues. So how do we curb the energy demand? So I'll briefly touch upon this. So when we talk about the Energy Conservation Building Code, it talks about different options. It talks about that how do we design our building envelope. Here comes the role of architects, here comes the role of designers. Do we have efficient HVAC systems? Then here comes, we are talking about the operational or the design part of this, efficient lighting, and there are different components. So, this is very important here, that if you go by the past trend, in the initial phases, we didn't have so much requirement for cooling in our buildings. But if you go by now, I have mentioned here room temperature up to 24, but the temperatures are much less than 24. And the annual energy consumptions are very high in commercial buildings today. So what is the right way? We all talked about, the joint secretary talked about the temperature setting. Mr. Bambure also talked about this. So one of the way which we see here is that if we can have some kind of a set point for temperatures and we can increase the temperature points, I think that is one way which we see here is that will help all of us to maybe address the cooling issues. So what we need here is that we need an integrated approach. So what I mean by integrated approach is that one is we need to talk about the building envelope part, which is the design part, where we talk about the wall optimization, roof optimization, fenestrations. Then we need to work on the lighting systems. HVAC system optimization is very important part here. And then it comes to the final building loads and consumption. I think then comes the issue of selecting efficient products. So this is how we see it. So what are the different options of reducing the cooling? We talked about that, the shading effect. Mr. Bambure just showed a picture that how the shading was useful. So we need to have a proper orientation of the building, efficient landscaping here, selection of energy efficient building materials. Again, one very important. So how I see this forum as a very important forum for our program is that whenever I interact with all the state authorities, the key question they have is that no, the energy efficient building materials are not available in our states. So that's a strange question. So what we are doing here is, so this is just for information of all the members, that in Odisha, we are starting with one initiative which is called, we are organizing a vendor meet, right? So, so on 12th of May, this is the indicative day, where you will have the ad in the newspaper also. So we are requesting all the material manufacturers, whether it is insulation providers, HVAC lighting, or the other materials, to provide that what is their capacity to provide materials in Odisha. And that initiative, then we will focus on all the other states in India. So that's one way. Then to address all these issues, we have the National Building Code, we have ECBC, we have different green building rating systems. We talked about this, that how do we get the heat in our building. We have a heat gain from roof, the walls, the glass daylight, the infiltration. So that's where we need to address that, how we address it. So this first picture, if you see this, here, one of the ways here is that if we go for proper orientation, if we go for roof shading, window shading, that is, so this is based on our experience. As I shared with you, we are coming up with 8 demonstration buildings in 4 states. Once we are done with that, we'll again come back to you with realistic case studies that when we did this, what are the actual results with us. So with our past experience and based on various simulation exercise, through a efficient design, the window shading, orientation, and all that, you save close to 10% in your cooling load requirements. This is indicative. Then energy efficient wall. We talk about insulation, high thermal mass, air cavity. So how do we achieve less cooling requirement in an insulated building is that we are going forward with materials which have lower U value, which is a overall heat transfer coefficient, and then somehow you are reducing the ingress of the heat to your building. And there are sufficient materials. We did one work 2 to 3 years back to assess the availability of building materials in India, and we have sufficient materials in the country. So it is just to adopt it. Then we can go for roof insulation. There are different materials available here. Glass, in comparison to single glazed windows, we can go for double glazed windows. We need to look at, of course, the cost economics. But all these things are available in the market, and our focus is that in next 6 months' time, we create sufficient awareness in the market that different technologies are available, materials are available, there's a directory available so that anybody can approach the material manufacturers. So
one more minute, please. 1 more.
2 minutes, that's it. So what is the impact on cooling load through efficient envelope? What we see here is that we can have a reduction close to 25 to 30% in the cooling load requirement. Lighting, again, it has an impact close to 5%. So if we combine efficient design, envelope, and lighting system, we get 30 to 40% drop in the cooling load requirements here. So this is all indicative I discussed with you. So when we are designing a building, I think we need to do some kind of a cooling load profiling before we select our chillers or we select our systems. We can do that. And yes, last thing which I would like to address here is, I think this is, so I'm just talking from the now efficiency side. We recently finished one work with Government of India. Rama was an active participant in that, and it was supported by US DOE. We developed the inverter AC labeling program in India, and at that time there was a discussion that the ISCR levels specified in the standard, they are very difficult to achieve. Then the government came up with a program called AC Challenge, and there was a discussion that what value we provide to the manufacturers, that what are the next level of efficiencies. Now, if you see the market now, you see a lot of inverter AC manufacturers which are well above the 5-star rating specified by BE. So I think these kind of initiatives also push, help us, all of us, to actually come forward with new set of technologies and new set of interventions. I think this is done from my side. So what I do here is, through this program, I think one way here is that we are addressing to engage all the architects in these 4 states, so that we discuss with them that how to design energy efficiency buildings. We are engaging with material suppliers. We are engaging with all the state level authorities. So the ultimate aim here is to come out with ECBC or ECBC design buildings so that we have the efficient performance. Yeah, thank you.
Thank you very much. And I think you highlighted again the need for integrated approaches here to bring in the architects. I think that now with the 3 presentations, what we can see,